Hey everybody, this is Dave Ritter and I'm going to show you the diamond method of factoring a quadratic equation. So it all kicks off with a x. So you create an x on your paper and then we surround it by this kind of imaginary line, dotted line here called the diamond. Alright, in this part here we would like to put let's change the font here. This part here is called the multiplication step. So usually people put an x here, but I'm going to put a times c because that's what we're doing. And it's just a little bit bigger and put our x there to signify multiplication. Let's center that up a little bit. Alright, next down here is our b term, or what our two factors, when we factor a and c, what they should add up to, which would be our b term. But we also can call this the addition step. So I'm going to put b here, and then just make this just a little tiny bit bigger, and put the addition step here. Whee! Okay. Also, what people generally do is kind of put a little arc here, kind of carding off the area here, signifying the type of operation that we're doing, so that it's separate from everything else. So just to remind you that we are doing the standard form of a quadratic, which of course is ax squared plus bx plus c. Alright. Sorry about that. There we go. And pointer is selected now. Alright. So here's our general form, and now we just need a particular quadratic to factor, where a is greater than 1. So 2x squared, oh I don't know, minus x, so minus 15. Yeah, I think that'll work. Okay. Here is our particular quadratic that we would wish to factor, and so here is our multiplication step. So we're going to take a times c. So 2 times negative 15 naturally is negative 30. So let's make this a touch bit bigger. So I'm going to put negative 30 up here. Down here is reserved for our b, and over here and here is reserved for our factor pairs of a times c, product here. So down here I'm going to put negative 1. Okay, so this is our goal. We need to find the two factor pairs of negative 30 that when added or subtracted will get us to negative 1. Those two factors will go, one will go here and the other one will go here. So let's go discover. Drag this out just a little bit. So we're looking for, what we did was we did 2 times negative 15, and that equals negative 30. Fair enough. So 1 times 30 will get us there. I'm not going to put the positive negative here, just for the sake of getting through this. So 2, looks like 2 will go into it, 3 will go into it 10 times, 4 doesn't work, 5 works though, so 5 times 6. Hey, great. 5 and 6 looks like when we add or subtract these will get us to negative 1. So these are our factors. So it looks like the negative will be attributed to 6 and 5. So 5 minus 6 is negative 1. Awesome. Okay, so now I'm going to put negative 6 in here, and this is just arbitrary. It doesn't matter where you put these. And I'm going to put the 5 in here. Okay. Now, this is where things get sticky, and some students don't like this step. I need to create two fractions. And as soon as you say fractions, some students have this visceral reaction. So anyway, the two factors will go in the denominator, and then traditionally people usually put 2x, and just for me, I like to put the product of this in here. So 2x times x would give us 2x squared. So I would put 2x and x, or 2x and x, you know, however you want to do it, x and 2x. But that usually leads, some students have difficulty with that. So what people usually do is put 2x here and 2x here. And I would say this is what generally creates the most amount of errors using this method, and why I generally don't use it. But for the sake of having another representation, this is cool. Okay, so now we want to reduce these fractions in these two boxes if possible. So 2x divided by -6 can be reduced to 1/3. So, or -1/3, sorry. So that cancels. I wanted to use my pencil tool here, but whatever, that works. Okay, and we want to put -3 down here. Okay, awesome. 2x divided by 5 cannot be reduced, so now what we're left here is a binomial here and a binomial here, and when we multiply those together we should get the original back. So now let's write out what's left. So it looks like we have x minus 3 here multiplied by 2x plus 5. And there we go. We've just factored this quadratic equation where a was greater than 1. If we FOIL this out or use the distributive property, we'll find that x times 2x is 2x squared. X times 5 is 5x. -3 times 2x is -6x. And -3 times a positive 5 is -15. So we will be left with x squared, and then 5x minus 6x is -1x, and -15, so it checks, and there you have it. So that's the diamond method, not to be confused with the lattice box method, which in a super small sample of 2 students, the lattice box method was the method of choice. This one here is a great method. However, I would say it breaks down right here when you kind of mess around with these fractions. But I'm sure after doing several of these in this algorithm style, I'm sure students would catch on. But there you have it.